Hello. Now we're going to build on the hyperbolic trig functions and show multiple ways of doing similar or doing the same trigonometric integral problems. So I have 3 problems lined out, and I'm going to show you how to do them in 2 different ways. So let's share. And there we go. First of all, let's start off with this following problem. Do this in 2 different ways. Now, the very first way, and this is the traditional trigonometric substitution, you see the 1 plus x squared. So the traditional is to let x equal tangent of t, or tangent of theta. It's really an arctangent substitution. And dx is going to be secant squared of t dt. So the integral now is transformed into, because 1 plus x squared is 1 plus tangent squared t, is secant squared t. So it's 1 over the square root of secant squared t, secant squared t dt. Okay? Now we understand now that secant is going to be positive over this range. It's positive. So notice that secant is going to be positive on minus pi over 2 to pi over 2. So we can now replace the square root of secant squared by secant. This just becomes the integral of secant, which you've learned in the earlier, is going to be the natural log of secant t plus tangent t plus c. And then if we do a substitution, now keeping in mind that x is tangent t, well, tangent is opposite over adjacent. So that's going to be tangent t. So this is going to be an x. That's going to be 1. This thing that I have right here is going to be tangent t. The Pythagorean theorem means that's going to be x squared plus 1. 1 squared plus x squared is that. And then you take square root. So when you take the secant of t, that's secant of arctangent x plus tangent of a tan of x. Well, the secant, of course, is hypotenuse over adjacent. So we get square root of x squared plus 1. And tangent of x, tangent is going to be x plus c. That's the first way of doing it. Now, using method 2, hyperbolic, you can, now we realize that this is really just going to be, we understand that this is going to be the same thing as the integral of hyperbolic, inverse hyperbolic of sine of x, if we will. But let's say we forgot that. So let's go ahead and use x equal hyperbolic sine of t. Dx is hyperbolic cosine of t. So this integral here becomes 1 over the square root of 1 plus sinh squared of t cos t dt. But remember what we learned before, we know that 1 plus hyperbolic sine of t is squared is hyperbolic cosine squared. So this whole thing here becomes 1 over the square root of hyperbolic cosine of t But this is positive, so this is canceled, so this is just dt. Okay. But that integral is easy to do because now to remember, x is, so t is of x, but then we've already gone through that. So so we've already gone through that. So this is now going to be, let's see, we got all that. So oops, that's an x. Or so we get now. The integral is in fact going to be the natural log of x plus the square root of x squared plus 1 plus c. Okay, so we got that. So that's part one. Now the second one is I'm going to go ahead and do this one in two different ways. Now the very first, now we actually know what this is going to be in advance. Because this is going to be the antiderivative of inverse hyperbolic cosine, which does have a expression. But let's say we don't know that. So the first way, let's just try to do it with a trig substitution. Let x equal secant t, because secant squared minus 1 is tangent squared. Dx is secant t tan t t. So this thing here becomes 1 over secant squared t minus 1 square root dx is secant t tan t dt. It's 1 over the square root of tangent squared. And notice this cancels. We'll just assume tangent is positive. And we've seen this before. That's just like the last one. Now we set up our triangle. Now remember, x is secant t. Secant is going to be hypotenuse over adjacent. And remember that 1 squared plus whatever this squared is equal to that squared. So in order to solve for this, that's going to be x squared minus 1 squared. Take the square root. Okay, so this squared plus that squared is that squared. Okay, so this transforms back to the natural log. Remember, this is secant t, so it's going to be x plus tangent is going to be square root of x squared minus 1 over 1. So, and that goes out pretty easily. On the other hand, the second way, and again, assuming we forgot it was a direct antiderivative, which it is, we can try x equal hyperbolic cosine. Dx is, that's nice. So we now have 1 over the square root of cos squared t minus 1. This on the bottom, that's just going to be hyperbolic sine square rooted. And those cancel as before. So this turns out to be the integral of dt. which turns out to be t plus c. But remember, t is going to be hyperbolic cosine inverse x. And we went through that long song and dance if you forgot, but we understand that I want to pull this up right here. We developed that in the last video, this relationship right there. This one I'm going to use. So it's going to be, in this case, plus c. That's going to be the integral. Okay? That's integral number 2. I'll be posting these all in the course notes blog. Now, the very last one, it's going to involve a little bit more work. It's this one right here. Now, the standard way is we use x is equal to tangent of t because it's a 1 plus x squared. And dx is secant squared t dt. So this integral is transformed into the square root of secant. And assuming that secant is positive, this turns into 1 power secant, and we get the secant cubed integral. Now, we can do the secant cubed integral by a reduction formula because we've already know how, in theory, how to do these with reduction formulas. Or we can just grit our teeth and just do it by parts. And let's go ahead and do that because it doesn't hurt to practice. And if we use the integration by parts formula, which is this, this will go ahead and be our dv because it's easy to calculate. This will be your u. So this is going to be secant t tangent t minus integral of e to u. Excuse me. So it's tangent. There's your there. And your du is secant tangent. Now this may look like it's a bad integral. But remember, this is a tangent squared here. So tangent squared we can rewrite as secant squared minus 1. We have a secant t dt. So we now have the integral of secant cubed is now secant t tan t. Now I'm going to do a minus. That's going to be the plus the integral of the secant t dt. Subtract another factor of secant cubed. Now you see the secant cubed here? The secant cubed there? Those can be combined. So we end up with 2, adding these together, we get 2 secant cubed t is going to equal secant t tan t plus the integral of that. And I'll add on the plus c. Now this could be easily solved for. plus c. Now, we've almost got this down, but remember our original substitution with x is equal to tangent t. We throw out the old triangle. If x is tangent t, tangent is opposite over adjacent. So secant, in this case, secant of this angle is going to be hypotenuse over adjacent. So this is transformed into, well, these should be t's, but that's okay. 1/2 secant is going to be the square root of x squared plus 1. Tangent's just going to be an x, so I'll make that an x. That's going to be an x plus the square root of x squared plus 1 plus c. So we're done right here. Now finally, let's go ahead and do it the second way. Use x is equal to hyperbolic sine of t. So this now becomes the square root of 1 plus hyperbolic sine squared t. Derivative is hyperbolic cosine. But remember, that's going to be the square root of cos squared t cos t dt. So assuming that's positive, so that's going to be hyperbolic cos squared t dt. Now, this integral, any way you slice it, we're going to have to do an integration by parts. Now, there is a half angle formula that's associated, or a double angle formula that's associated with the hyperbolic trig functions. I'm going to assume we don't know that. So I'm going to use a u equal cos t dv is cos t dt. For the integration by parts formula, we get, well, du is sinh, and now v is sinh, du is sinh. This, of course, should look very familiar because derivative, we understand that sinh squared plus 1 is cos squared. So what you have to do is you, since sinh squared plus 1 is cos squared, to solve, we have to take away 1 right here, way back this thing. So what we have is we have the sinh squared on this side, so it's going to be cos squared minus 1. That now carries over as follows. It's going to look very familiar. It's the same trick as we did last time. Minus a minus is a plus. Minus. But remember what this originally was. This originally was the integral of cos squared. We have that over this, so we now know 2 cos squared by adding this to both sides is going to be cos t sinh t plus integral of t dt is just t. So the whole integral is going to be 1/2. All right, so now what we're going to have to do is we're now going to have to retransform. But remember, the original thing was x is sinh t. So if x is sinh t, this is going to be the square root of, because remember, sinh t is cos squared t minus 1. So what you do now is we got to solve for cosh, so that's what this is. So this is equal to 1/2. That's this cosh part right here. Sinh. And remember, this is t was going to be the inverse. This t is going to be the inverse hyperbolic sine. And we've gone through that again. We have it right there. So it's going to be 1/2 natural log of x plus the square root of x squared plus 1. That's this part right here. That's going to be 1 plus x squared, because now we got it this way. We have an x. Now, I'm not so sure this was any easier, but it was a second way. So we've done 3 intervals, and I'll have to see how much time, and we'll stop the share, and I'll see you next time.